Reviewing simplifying radicals, remember your perfect square list is generated time 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. And you keep going. This list goes on forever. I stopped at 15 times 15, which is 225 because it says the first 15 numbers. All right, so 32. We broke down 75 into all of our prime numbers, 3, 5, and 5. Wrote them in order. 5 times 5 is 25. So 5 times 5 is 25. What is the square root of 25? What's the square root of 25? 5. So 5 comes on the outside. The 3 is on the inside. And that's your answer. All right, let's do a bigger number, 448. Give me a number that goes into 448. $16? You just choosing random numbers? Sure, 16 worked. Interesting. So 16 and 28? Neither of those are prime, so we gotta keep going. What multiplies to 16? 4 and 4? Or 2 and 8? Those aren't prime because what multiplies to get you 4? 2 and 2. Okay, those are prime numbers. Another 4, so we gotta break that again. 2 and 2. And I don't need to see this work. You can do this on the side. You can do this on a separate sheet of paper. You can do this in the odd numbers since we're only working the even numbers. We gotta keep going on 28. 28 can be 2 and 14. 14, 2 is prime, 14 is not. And then what multiplies to 14? 2 and 7. And 7 is prime. So everything you circled goes under your radical. 6 2s. And 1 7. Eight, 7.
So 8 on the outside.
7 on the inside because that doesn't have a group. So 7's going to be on the inside. And every group you pull one out. So I'm going to pull out 1, 2 from this group. The other one goes away. One group, 2 from that group. The other one goes away. So you said 2 times 2 times 2 is 8. So 8 squared 2. Yep. Because 2 times 2 is 4. And the square root of 4 you know is 2. So that's why 2 comes on the outside. 2 times 2 is 4. The square root of 4 is 2. 4, the square root of 2. Oh, yeah. Thank you. My bad. I would be too. I was completely wrong. Sorry. All right. Then our perfect cubes. We're going to do the first 10 because they jump up a lot quicker. 1 times 1 times 1 is 1. 3 times now. That's what a cube is. 2 times 2 times 2 is 8. 3 times 3 times 3. 27. 4 times 4 times 4. I want to guess 64, but honestly, I'm not sure. So 4 times 4 times 4, 64. Or the easier way to do that, 4 raised to the third, 64. 5 raised to the third, 125. 6 raised to the third, 216. 7 raised to the third, 343. And I don't care if you memorize this list as long as you know how to get it. 8 raised to the third. Because I don't even have these memorized. I have the first few memorized, the easy ones, but then the numbers get pretty big.
And then you had the last one.
Anytime you multiply by 10, like 10 times itself is just how many zeros. So if I'm going to multiply 10 3 times, that's 3 zeros. 10 times 5, 1 with 5 zeros after. That's how I memorize that. But no, I don't have it memorized. But yeah. All right, we'll do the evens. So we're going to break down 48. What gives me 48? It's even, so you can always use 2. So you could always use 2 and 24. But you said 8, so 8 and 6. That works too. Those are not prime. 2 and 3 are. The bigger numbers you choose, the quicker this list gets done. So if I did 2, this list would be really long. 2 and 4, 2 and 2. Oh, 4 is not prime. Why did I circle that? Go away. You're only circling your prime numbers. For my people at home still having trouble with your prime numbers, let's make up a list real quick. So prime numbers. Prime numbers are numbers that the only way you can get it is multiply it by 1 in itself. So if you can say like 2 times 3 is 6, 6 is not a prime number. And it keeps going, but 17 is usually the highest you're going to see. So those are the numbers in your tree that you'll circle.
So it's 2 and 3 and so
Did you group in threes? Because it's the cube root?
yes.
So the only difference between what we were just doing, square roots, and cube roots is now every 3, 1 comes out. So I have 1, 2, 3, 4. 1, 2, 3, 4 2s and 1 3. So square root, you group in 2s. Cube roots, root in 3s. So every 3, 1 comes out. Every 3 of the same number. That's what that little index of 3 is saying. So make sure you have that 3 on your answer or it's going to be wrong. So 2 times 2 times 2 is 8. And you should know the cube root of 8. The cube root of 8 is 2. The cube root of 1 is 1. The cube root of 27 is 3. The cube root of 64 is 4. The cube root, that's why we made this list. So the cube root of 8 is 2. Every 3, 1 comes out. There's no group of 3 from 2 and 3, so you just multiply those together. You get 6. One away. I'm going to just, it's even, I'm going to just do it by 2. So if this is the way you're going to do it every time, that's okay. So 108 divided by 2 is 54. 54 is even. So again, I'm going to divide that by 2.
I did it by
27. Okay, that works. 27 is not even, so I can't use 2 anymore, but I can try 3. 3 and 9. And then 9 is 3 and 3. So it doesn't matter what number you start with. What number did you do? 4 and 27? 2 and 2. 3 and 9. Oh, 3 is prime. 3 and 3. So if you see, I have 1, 2 2s, 1, 2 2s, and 3 3s. So it doesn't matter what numbers you choose, you should always end up with the same prime numbers when you break it down.
So everything was 4 and 5. And 2 times 2 is 4. Yeah.
Correct. Every 3, 1 comes out. The other 2 disappear because 3 times 3 times 3 is 27. So this whole circle equals 27. And the cube root of 27 is 3. So that's why only 1 comes out. The others disappear. And then 2 times 2, we can't group in 3. So you just multiply them back together and you get 4.
So technically, 2 times, you could leave 2 times 2 there. It's just not completely.
Yeah. We're just doing the evens. If you want to go back and need help with odds, I can definitely do that. Let's add some variables. Break down 24. This is a square root because there's no number, so we're grouping in 2s. It's even, so you can do 2. 4 goes into it, so you could do 4 and 6. But I'll stick with 2 and 12. You do your numbers. Again, it's even, so 2 goes into it. 2 times 6 gives me 12. 6 even, so 2 goes into it. And 3 is also prime, so you're done. Okay, the new part of this question is your variables. X squared is 2x's. And then you're grouping in 2s.
There's 2 X on the outside and 6 on the
So when you group, only 1 comes out. Oh, okay. Not 2x's, 2x is what you said. Yeah, so 2 came on the outside and 1x comes on the outside and the other numbers in the circle go away. And then what's left underneath is 2 times 3. Which you can leave it 2 times 3, that'd be right, but we want it in the simplest form, so that'd be 6.
See, it looks kind of different, like, I know, I did when I look at it, but when you write it like that, it's less.
On Delta Math assignment today, there's numbers on the outside, so I'm just going to add a 3 to this number. I know there wasn't one, like a big 3. So I'm 3 square root 72p to the 16. That's what I'm going to be doing. I just added a 3 in the front. So when you do your Delta Math, you know what to do if there's a number in the front.
Oh, so it's not.
So if there's a number in front, anytime you pull a number out of your group, you multiply it. Some people try to add it, so I just wanted to make sure you see that again. It's even, so 2 and 36. Even again, 2 and 18. Even again, 2 and 9. It's odd, so I'll divide by 3, and that's 3 and 3. Not always the easiest way to do it. You could have done, what is it, not 8 and 9? 2 and 4. This is, people get really quick at this if they're good at their multiplication table. But no matter how you break down 72, you should have 3 2s and 2 3s. So I'm ignoring this 3 that I put on the outside. I'm going to do 3 2s, 1, 2, 3, and 2 3s. And I have 16 p's. And you can write them all out. 1, 2. Right over here. But if you think about it, you shouldn't have to write them out. If you have 16 p's and you're grouping them in 2, how many groups do you have? 16 grouping in 2s.
Oh,
8. I have 8. So what you did in your head was you did 16 divided by 2 and you got 8. So that means I'm going to have 8 groups of P, and you're going to put 8 groups of P on the outside. So if you don't want to write down 16 P's, I don't blame you because I didn't want to do it. So just divide your exponent of your variables, this number, by 2, and that's how many will be on the outside. So I had 8 groups of P's, and 8 comes on the outside. We're grouping in 2s because this is square root.
18 on the outside. And then
There's totally ahead of me. So there's already a 3 outside, so I'm going to leave that there. I have a 2 that comes out and a 3 that comes out. And I had a 2 left and then no variables left at all. So square root 2, p to the 8th, and then multiply all that. 3 times 2 is 6, times 3, 18. All right, just to get better practice of what your delta math looks like, I put a 3x on the outside. And then I'm going to break down 320. I'm going to pause the video so you don't have to waste your time on the video breaking down 320. Hopefully you're good at it now. All right, I broke down 320 to 1, 2, 3, 4, 5, 6 2's times 1, 5. And that's very easy to make a mistake and like not have counted enough 2's. So I'm just going to check 1, 2, 3, 4, 5, 6 2's and 1, 5 is 320. So I didn't make a mistake. X to the 18. Or you can write 18 x's down. I didn't even want to write 16 x's, so I don't want to write 18 x's personally. 9. So if you're grouping 18 x's in groups of 2, there's going to be 9 of them, 9 groups of 2. So 3x is already on the outside, and whatever I bring out of here is going to get multiplied to that 3x. Every 2, 1 comes out. Every 2, 1 comes out. Every 2, 1 comes out. So a 2, a 2, a 2. Or if you want to just go ahead and put that in a calculator and get 8, makes it a little easier. And then if I'm grouping 18 x's in groups of 2, you get 9 because 18 divided by 2 is 9. And a 5's left on the inside.
So 24.
That's what 3 times 2 times 2 times 2 is? 24. X to the 10. Because there's already one outside and I brought 9 more. So that's why it's 10.
I'm proud about that.
I don't know what goes in there. It's not 2 because it's odd. Let's see if 3 goes into it. Oh, 3 goes into it. Do you know the divisibility trick of 3's? Like how you know if it's divisible by 3? If you add the numbers, the digits together, that's a 7. 1 plus 4 plus 7 is 12. And if this number is divisible by 12, then the big number is divisible by 12. Not 12, 3. Apologize. If 1 plus 4 plus 7, if the digits add up and give you a number divisible by 12, a number divisible by 3, then this number is divisible by 3. I like that. I think that's a odd rule that works for some reason. All right, so we have 3 times 7 times 7. Last one, guys. I think you get it.
Does the dividing into 2 only work for
Even numbers. Yeah, that's why I wanted to do one with that odd. So let's do the number first, and then we'll worry about the variables. 7 coming outside. 3 stayed on the inside. All right, if I have 15 C's, and I divide that by 2, why is it lagging? Like, you made me write 7. 15 divided by 2 is 7 and a half, or 7.5. So you can make 7 groups of C's. So I'm going to pull a 7 out. And that means there's 1 left in. And if you don't get that, you can write out 15 C's. Three, 4, 5, 6, 7. So I have 7 on the outside, and then this one wasn't circled, so it's left on the inside. The video, I think on Delta Math, shows you if you have C to the 15th, that's C to the 14th times C. Oh, that was D. So that, because 14 divided by 2 is 7, and then there's 1 left on the inside. So they just tried to make it, they went to the next even number. So the next even number from 15 is 14, and then 1. And then if I have 20 D's, it's 10. D to the 10th. And that's your answer. And if you've gotten this far, I think you get it. So I'm going to stop with the notes today. And you can do your Delta Math assignment. And if you get stuck on one, I'll come help you.